What's up guys, welcome to your another C programming tutorial, and in this tutorial we'll do actual programming. This is Ashish from alibrary.in, and the first program which we'll start up with is a simple factorial program using function. So guys, I've just written down the program for factorial, and as you can see, first let me tell you what factorial is. For example, if I say find the factorial of say 5, so the factorial of 5 will be 5 into 4 into 3 into 2 into 1. Okay, the multiplication of all of those, I think it comes around 120. So 5 factorial will be that way. And if I say find the factorial of 3, so it'll be 3 into 2 into 1. Okay, so that will make it to 6. So in this program what we will do is we'll just find factorial of number from 0 to 10. Okay, so what I've done here is I've just prototyped a function. I'll just call it long. It's short for long int, because the factorial number will be very huge. I'll just show you in a while. Okay, then I've taken to a variable int I for my for loop, and here what it'll do is it'll just give two spaces, and then it'll put the value of I over here, which will be 0 through 10. So because we'll find the factorial from 0 to 10, and in the next parameter it'll take the value which will be returned from this function factorial. So we just take this factorial number, we pass the value of I to this factorial, and it'll jump straight over here to this function. And what it'll do over here is, first we have passed a condition that if the number is less than or equal to 1, return 1, because we know that the factorial for 0 is 1 and factorial for 1 is 1. And in the else part, if it is not 1, what we have done here is we have taken the number, whatever the input, and multiplied by the factorial of the previous number. Let me just show you how it is done. So for example, if I say we have to find the factorial of 5, so how we have programmed here is we just take the number 5 and then we use the factorial of the previous number. Okay, so what this will do is the number 5 into the factorial of number 4. So by that we'll get this one. So we don't know the factorial of 4, so it'll find the factorial of 4 first. So 4 into 3 factorial, then it'll come over here, and again 3 factorial it'll take, then 2 factorial, then 1 factorial. So in that way we can get the 5 factorial. This is, I guess, one of the easiest way to find the factorials. Okay, so let me just build and run it. So as you can see, we have just left nice two spaces over here, and there you go. 0 factorial is 1, 1 factorial is 1, and this is why it took long integer, because the numbers will be pretty big. So I hope you understood about the factorial, and we'll move on to the next program. So now getting into our another program. This is Fibonacci series, and I've just written down the program again to save a lot of time. Okay, so what Fibonacci series is, I'll just show you in Paint. So this is Fibonacci series, and what this will do is if I say find f of, it'll start with 0 and 1. Okay, keep that in mind. And if I say find f of 2, it'll be simply the addition of the previous two. Okay, so for example 1 plus 0, it is 1 over here. So if I say find f of 3, it is 1 plus 1. Okay, then if I say f of 4, it is 2 plus 1. So in short, we can make out that if I say find f of n, okay, if I say f of n, it should be f of n minus 1 plus f of n minus 2. Okay, so now this is the Fibonacci series. This is the actual series, how you represent it. Okay, so we could make out, so for example, if I say find f of 10, it will be the addition of previous two, which is 21 plus 34, which would give out 55. Okay, so let's make the program for this one. So what I've done here is I've just prototyped the function. I've just called it, I just made it like it'll receive a long and it'll return a long. Okay, long integer. So inside the main, I've taken two variables, result and long. Okay, result and num. Okay, number is over here and num is over here, and I just prompt the user to enter the number. Okay, whichever he wants to find out the value of, say, f of 0 or f of 20, whatever, and I'll store that value inside result. So that's the case. That's the reason I took result as long, because that'll print out the digit might be long, as we saw here. When we go further, the digit gets longer. So I'll call it, it'll jump over here, the control shifts to this function, and I'll check whether the number is 0 or the number is 1. Either cases, it'll print out the number itself, and if it does not, I will just take the previous value of it. Say if the number entered was 21, so it'll be the f of 20 plus f of 19. 21 minus 2 is 19. So again, it'll find the f of 20 and f of 19 in the same way. It'll figure out everything for us and finally print out the value. So let's just build and run it. So if I say I want the value of, say, 6, so it is 8. We'll just check it with our table over here. And 6, if you go, it is 5 plus 3, and it's 8, and it's correct. So let's see for 20. Build and run. If I say 20, it'll print out this value. Okay, so that is how it is. That is how Fibonacci series works, and we'll see our next program. Guys, I've just written down a program for linear search. What linear search does is if you see, I'll just show you once. You'll ask enter the search key. It's nothing but what is the number that I want to find out. I want to find out whether the number is there in that array or not. Okay, so let me start with a simple one. Let me say if I press 2, so it says found the value in element 1. So what that means is, in element 1 means is that it is the second element. Okay, like you go like the array name is A over here, so A of 0 and A of 1, it will be in A of 1. Okay, so let me just walk you through it in this program. So I've just defined the size over here to 20, and I've just prototyped the function. And remember, the const over here, this will make this array unmodifiable. You cannot change the array. Okay, then this will accept an key, that is the value which we have to find, and the size is basically the size of the array. Okay, so coming into the main program, I've just defined the array. I've just called it A. It is an integer type, and the size is 20. Okay, and the value X, I've taken it from a for loop, and the search key, it will be the number which we have to find. Okay, and the element is the element, that is the position where it will be, like I showed you in the block. Okay, so I will find where it is, and in the for loop we'll just fill up all the elements in the array with the multiples of 2. So 0 into 2 will be 0, so A of 0 will be 0, A of 1 will be 2, and so on and so forth. Okay, then I prompt the user to enter the search key, whichever the key he has to search. I'll just scan it, and we'll just take the input from the user. We'll store the value of the element, that is the position in which if we find the key, we'll just print out that number. Okay, and if we don't, we'll just print out the value not found. Okay, we'll just call the function over here, and it'll jump right over here. And here I've just taken an int n from a for loop, and what this will, in this loop, I've included a condition that if the array, okay, if the array and n, it'll loop through 0 to less than that of the size, that is till 19. Okay, so it'll check individually. Array of 0, is it equal to key value? Say if he enters 2, is array of 0 equal to 2? It'll check for all the 19 or the 20 elements. It'll check all, and if it is found, it'll print n. If it is not found, it'll print minus n, and it'll say no, it's not found. Okay, if it is not equal to -1, then that means it returns an n. So it'll print out the element. I'll just show you that. So if I say 14, it says found the value in element 7. So what this did was, let's come over here. So it looped, like I asked him to search the key, that is 14, so it'll come to array of 0, is it'll check is array of equal to 14, no, then it'll increment it, is array of 1 equal to 14, no, and it'll go on till array of 7. It'll see is array of 7 the seventh, or the eighth element in this array, is it equal to key? Yes, it is. So it'll give away the value of the element, which is 7 over here. Okay, so that is how you do it. But in the linear search, it'll go one by one, starting from the first element till the last element of the array. It'll go one by one and search if the value is present there or not. So that was it for the linear search. So guys, this is a program on binary search. Okay, so I'll just show you what binary search is. So now enter a number between 0 and 18. I say I enter 6. So what binary search is, now for example, this is my array. Okay, this is my array list from 0 to 19, all multiples of 2. Now binary, it means only 2, 0 and 1. So binary digit will split the whole array into 2. Okay, this is one half and this is another half. Okay, now if by chance this itself is searched, the element which we are searching, then it'll print out this one. Okay, the binary search, it will reduce the effort, it will reduce the time. Now say if my element to search was 14, so what would have happened is it would have discarded all the elements over here, then it would have taken half of this one, and it would have taken the middle of this one, from 10 to 18. It would have taken the middle of this one, which was 14, and it would have given the key was, if it was 14, and it would have founded it out. So that is how it is. It'll be splitting the whole array into two halves, and it'll check whether the key element to be searched, whether it is greater than the middle element or whether it is less than. In either ways, if it is greater than the middle element, it'll discard all the rest of the element, and if it is by chance lesser than, it'll discard this part, and again it'll divide this part into half, and this thing goes on until only single element is left. Okay, so now let me walk you through this code. Now just define the size as 10, and I've just defined the three functions. Okay, the first function will be the main binary search, and what this will do is we have put const again, so it is it doesn't change, the array doesn't change. And what this will say is, hey, I'm expecting an integer, and search key, all these are normal integer variable, and this is just for display purpose to make it look a little neat, and this will print out the row, the values. Okay, so coming to the main program, I've just defined an array of size 10, and I've taken I for my for loop, the key to be searched, and the result, which we will store, the element which we will find out. So I've just initialized my array, and I've prompted the user to enter a number between 0 and 18. That's it. So I'll just read the input using scanf over here, then I'll print the header. Now let me tell you what print header does. Where is it? Yeah, there it is. Print header, it'll just take an I from a for loop, and this is the subscription. I'll just show you over here. If I add 16, so there it is. Now subscription, now what this will do is I want it to add the subscripts. Okay, from 0 to 9, because my array size will have 10 elements, so I put 0 to 9. Okay, and then I've printed a new line and given this dashes over here to differentiate between the subscripts and the actual array element or the values. Okay, and it will come out in the new line. So print header was basically to give out the look for the program so that we can make out what does. And then after the print header, we'll come over here, we'll store the result. For that, we call this binary search function, and in the binary search function, what we will have input is the array itself. The array name was A, so I'll put an array, then the key to be searched, then the low, I've initialized it to 0 because array always starts from 0, and the size will be A of 9, so size will be 10 minus 1, it will be 9. Size was 10, so it'll be 9. Okay, so now I've taken a variable called middle to find the middle value. As I said, binary, it'll find the middle value and then it'll see if it is higher or lower the element to be searched. Now middle is simply the low plus high by 2. So middle will be 0 plus 9 by 2, which comes around 4.5. It'll point to this one, fifth element. Okay. So now this ash, the symbol, the star symbol over here represents this is the middle element. Okay, and where here it'll then it'll call the print row. Okay, so it'll jump the control will be moved over to print row function, and this function will again accept an array at the low, mid, and high. Now what this function basically does is it'll find the middle element and put the star over there. So you have just like this 8 was a middle element, it gave 3 spaces and put a star to it. So b of I, this was the element. Okay, b of I had some value, I guess 8 over here, so it printed out the value of it with a star to point out that this is the middle element. Similarly to all this middle element, the print row does the same operation. Okay, so after print row is done, it'll come back over here and this one, and it'll check if the search key is equal to the middle. It'll return the middle value, and that's it. It will say that we have found the value. If it is not, what we will do is we'll start compressing it. So for example, we had to find a 16 over here, right? So what we did was just it took this half of it, this half, and it took the middle one of it. So 14 was the middle one for this one, and then within these two, so it pointed to the 16th, the 8th element, and we wanted this element 16 itself. So it just found out that the element which you were, the number which you were finding is in element 8. Okay, so that is how it is. uh, it'll be, now what this says is high, like high will be over here 9. You'll decrement it, so it'll come over here and it'll start searching. And low was, I guess it was at 6, so you'll increment it, it'll come at 7, so it'll start searching this way. Finally it'll return you the values. Okay, so this is how binary search is. The main thing you should take away from this is binary search, it divides the whole array into two. It'll check whether the key to be found is greater than the middle number or is it less than the middle number. If it is greater than the middle number, it will discard all the low values and find again the middle out of the greater numbers. Okay, and again it'll find the middle numbers unless it has two values, and finding the numbers from two values will be a lot easier and it'll be a lot time saving. So the binary search gives the result faster than linear search. Okay, so that's it for this tutorial, guys. I hope you liked it. I hope you learned a lot from this, and I'll see you in the next tutorial. Bye.